An intelligence quotient is a total score derived from one of several standardized tests designed to assess human intelligence. The abbreviation IQ was coined by the psychologist William Stern for the German term Intelligenzquotient, his term for a scoring method for intelligence tests he advocated in a 1912 book. Historically, IQ is a score obtained by dividing a person's mental age score, obtained by administering an Intelligence.The, by the person's chronological age, both expressed in terms of years and months. The resulting fraction is multiplied by 100 to obtain the IQ score. When current IQ tests are developed, the median raw score of the norming sample is defined as IQ 100 and scores each standard deviation up or down are defined as 15 IQ points greater or less, although this was not always so historically. By this definition, approximately two-thirds of the population scores between IQ 85 and IQ 115. About 5% of the population scores above 125, and 5% below 75. IQ scores have been shown to be associated with such factors as morbidity and mortality, parental social status, and, to a substantial degree, biological parental IQ. While the heritability of IQ has been investigated for nearly a century, there is still debate about the significance of heritability estimates and the mechanisms of inheritance. IQ scores are used for educational placement, assessment of intellectual disability, and evaluating job applicants. Even when students improve the scores on standardized tests, they do not always improve the cognitive abilities, such as memory, attention and speed. In research contexts, they have been studied as predictors of job performance and income. They are also used to study distributions of psychometric intelligence in populations and the correlations between it and other variables. Raw scores on IQ tests for many populations have been rising at an average rate that scales to 3 IQ points per decade since the early 20th century, a phenomenon called the Flynn effect. Investigation of different patterns of increases in subtest scores can also inform current research on human intelligence. History. Precursors to IQ testing. Historically, even before IQ tests were invented, there were attempts to classify people into intelligence categories by observing the behavior in daily life. Those other forms of behavioral observation are still important for validating classifications based primarily on IQ test scores. Both intelligence classification by observation of behavior outside the testing room and classification by IQ testing depend on the definition of intelligence used in a particular case and on the reliability and error of estimation in the classification procedure. The English statistician Francis Galton made the first attempt at creating a standardized test for rating a person's intelligence, a pioneer of psychometrics and the application of statistical methods to the study of human diversity and the study of inheritance of human traits. He believed that intelligence was largely a product of heredity. He hypothesized that there should exist a correlation between intelligence and other observable traits such as reflexes, muscle grip, and head size. He set up the first mental testing center in the world in 1882, and he published Inquiries into Human Faculty and its Development in 1883, in which he set out his theories. After gathering data on a variety of physical variables, he was unable to show any such correlation, and he eventually abandoned this research. French psychologist Alfred Binet, together with Victor Henry and Theodore Simon, had more success in 1905 when they published the Binet-Simon test, which focused on verbal abilities. It was intended to identify mental retardation in school children, but in specific contradistinction to claims made by psychiatrists that these children were sick and should therefore be removed from school and cared for in asylums. The score on the Binet-Simon scale would reveal the child's mental age. For example, a 6-year-old child who passed all the tasks usually passed by 6-year-olds but nothing beyond, would have a mental age that matched his chronological age. 6.0. Binet thought that intelligence was multifaceted, but came under the control of practical judgment. In Binet's view, there were limitations with the scale, and he stressed what he saw as the remarkable diversity of intelligence and the subsequent need to study it, using qualitative, as opposed to quantitative, measures. American psychologist Henry H. Goddard published a translation of it in 1910. American psychologist Louis Terman at Stanford University revised the Binet-Simon scale, which resulted in the Stanford-Binet intelligence scales. It became the most popular test in the United States for decades. General fact: the many different kinds of IQ tests include a wide variety of item content. Some test items are visual, while many are verbal. Test items vary from being based on abstract reasoning problems to concentrating on arithmetic, vocabulary, or general knowledge. The British psychologist Charles Spearman in 1904 made the first formal factor analysis of correlations between the tests. He observed that children's school grades across seemingly unrelated school subjects were positively correlated, and reasoned that these correlations reflected the influence of an underlying general mental ability that entered into performance on all kinds of mental tests. He suggested that all mental performance could be conceptualized in terms of a single general ability factor and a large number of narrow, task-specific ability factors. Spearman named it G4, general factor, and labeled the specific factors or abilities for specific tasks S. In any collection of test items that make up an IQ test, the score that best measures G is the composite score that has the highest correlations with all the item scores. Typically, the G-loaded composite score of an IQ test battery appears to involve a common strength in abstract reasoning across the test's item content. Therefore, Spearman and others have regarded G as closely related to the essence of human intelligence. Spearman's argument proposing a general factor of human intelligence is still accepted in principle by many psychometricians. Today's factor models of intelligence typically represent cognitive abilities as a three-level hierarchy, where there are a large number of narrow factors at the bottom of the hierarchy, a handful of broad, more general factors at the intermediate level, and at the apex a single factor, referred to as the G factor, which represents the variance common to all cognitive tasks. However, this view is not universally accepted. Other factor analyses of the data, with different results, are possible. Some psychometricians regard G as a statistical artifact. United States military selection in World War I. During World War I, a way was needed to evaluate and assign Army recruits to appropriate tasks. This led to the rapid development of several mental tests. The testing generated controversy and much public debate in the United States. Nonverbal or performance tests were developed for those who could not speak English or were suspected of malingering. After the war, positive publicity promoted by Army psychologists helped to make psychology a respected field. Subsequently, there was an increase in jobs and funding in psychology in the United States. Group intelligence tests were developed and became widely used in schools and industry. L. Thurston argued for a model of intelligence that included 7 unrelated factors. While not widely used, Thurston's model influenced later theories. David Wexler produced the first version of his test in 1939. It gradually became more popular and overtook the Stanford Binet in the 1960s. It has been revised several times, as is common for IQ tests, to incorporate new research. One explanation is that psychologists and educators wanted more information than the single score from the Binet. Wechsler's 10 or more subtests provided this. Another is that the Stanford Binet test reflected mostly verbal abilities, while the Wechsler test also reflected nonverbal abilities. The Stanford Binet has also been revised several times and is now similar to the Wechsler in several aspects, but the Wechsler continues to be the most popular test in the United States. Cattell-Horn-Carroll theory. Raymond Cattell proposed two types of cognitive abilities in a revision of Spearman's concept of general intelligence. Fluid intelligence was hypothesized as the ability to solve novel problems by using reasoning, and crystallized intelligence was hypothesized as a knowledge-based ability that was very dependent on education and experience. In addition, fluid intelligence was hypothesized to decline with age, while crystallized intelligence was largely resistant to the effects of aging. The theory was almost forgotten, but was revived by his student John L. Horn, who later argued GF and GC were only two among several factors, and who eventually identified 9 or 10 broad abilities. The theory continued to be called GF-GC theory. John B. Carroll, after a comprehensive reanalysis of earlier data, proposed the three-stratum theory, which is a hierarchical model with 3 levels. The bottom stratum consists of narrow abilities that are highly specialized. The second stratum consists of broad abilities. Carroll identified 8 second stratum abilities. Carroll accepted Spearman's concept of general intelligence, for the most part, as a representation of the uppermost, third stratum. In 1999, a merging of the GF-GC theory of Cattell and Horn with Carroll's three-stratum theory has led to the Cattell-Horn-Carroll theory. It has greatly influenced many of the current broad IQ tests. In CHC theory, a hierarchy of factors is used. G is at the top. Under it are 10 broad abilities that in turn are subdivided into 70 narrow abilities. The broad abilities are: fluid intelligence includes the broad ability to reason, form concepts, and solve problems using unfamiliar information and novel procedures. Crystallized intelligence includes the breadth and depth of a person's acquired knowledge, the ability to communicate one's knowledge, and the ability to reason using previously learned experiences or procedures. Quantitative reasoning is the ability to comprehend quantitative concepts and relationships and to manipulate numerical symbols. Reading and writing ability includes basic reading and writing skills. Short-term memory is the ability to apprehend and hold information in immediate awareness, and then use it within a few seconds. Long-term storage and retrieval is the ability to store information and fluently retrieve it later in the process of thinking. Visual processing is the ability to perceive, analyze, synthesize, and think with visual patterns, including the ability to store and recall visual representations. Auditory processing is the ability to analyze, synthesize, and discriminate auditory stimuli, including the ability to process and discriminate speech sounds that may be presented under distorted conditions. Processing speed is the ability to perform automatic cognitive tasks, particularly when measured under pressure, to maintain focused attention. Decision reaction time. Speed reflects the immediacy with which an individual can react to stimuli or a task. See mental chronometry. Modern tests do not necessarily measure all of these broad abilities. For example, GQ and GRW may be seen as measures of school achievement and not IQ. GT may be difficult to measure without special equipment. G was earlier often subdivided into only GF and GC, which were thought to correspond to the non-verbal performance subtests and verbal subtests in earlier versions of the popular Wechsler IQ test. More recent research has shown the situation to be more complex. Modern comprehensive IQ tests do not stop at reporting a single IQ score. Although they still give an overall score, they now also give scores for many of these more restricted abilities, identifying particular strengths and weaknesses of an individual. Other theories. J.P. Guilford's structure of intellect model used 3 dimensions which when combined yielded a total of 120 types of intelligence. It was popular in the 1970s and early 1980s but faded owing to both practical problems and theoretical criticisms. Alexander Lurier's earlier work on neuropsychological processes led to the pass theory. It argued that only looking at one general factor was inadequate for researchers and clinicians who worked with learning disabilities, attention disorders, intellectual disability, and interventions for such disabilities. The PASS model covers 4 kinds of processes. The planning processes involve decision-making, problem-solving, and performing activities and requires goal-setting and self-monitoring. The attention-arousal process involves selectively attending to a particular stimulus, ignoring distractions, and maintaining vigilance. Simultaneous processing involves the integration of stimuli into a group and requires the observation of relationships. Successive processing involves the integration of stimuli into a serial order. The planning and attention-arousal components comes from structures located in the frontal lobe, and the simultaneous and successive processes come from structures located in the posterior region of the cortex. It has influenced some recent IQ tests, and been seen as a complement to the Kittel-Horn-Carroll theory described above. Current tests. There are a variety of individually administered IQ tests in use in the English-speaking world. The most commonly used individual IQ test series is the Wechsler Adult Intelligence Scale for adults and the Wechsler Intelligence Scale for children for school-age test takers. Other commonly used individual IQ tests include the current versions of the Stanford-Binet-Woodcock-Johnson tests of cognitive abilities, the Kaufman Assessment Battery for Children, the Cognitive Assessment System, and the Differential Ability Scales. IQ tests measuring adult intelligence also includes Stanford-Binet Intelligence Scales, Woodcock-Johnson tests of cognitive abilities, Raven's progressive matrices, Wechsler Adult Intelligence Scale, Cattell Culture Affair 3, Reynolds Intellectual Assessment Scales, Thurstone's Primary Mental Abilities, Differential Ability Scales, Kaufman Brief Intelligence Test, Multidimensional Aptitude Battery 2, Das Nalierli Cognitive Assessment System. IQ scales are ordinally scale, while one standard deviation is 15 points, and 2 SDs are 30 points, and so on. This does not imply that mental ability is linearly related to IQ, such that IQ 50 means half the cognitive ability of IQ 100. In particular, IQ points are not percentage points. On a related note, this fixed standard deviation means that the proportion of the population who have IQs in a particular range is theoretically fixed, and current Wechsler tests only give full-scale IQs between 40 and 160. This should be borne in mind when considering reports of people with much higher IQs. Test bias or differential item functioning. Differential item functioning is sometimes referred to as measurement bias, is a phenomenon when participants from different groups with the same Latent abilities give different answers to specific questions on the same IQ test. DIF analysis measures such specific items on a test alongside measuring participants' latent abilities on other similar questions. A consistent different group response to a specific question among similar type of questions can indicate an effect of DIF. It does not count as differential item functioning if both groups have equally valid of chance of giving different responses to the same questions. Such bias can be a result of culture, educational level and other factors that are independent of group traits. DIF is only considered if test takers from different groups with the same underlying latent ability level have a different chance of giving specific responses. Such questions are usually removed in order to make the test equally fair for both groups. Common techniques for analyzing DIF are item response theory-based methods, Mantel-Hansel, and logistic regression. Reliability and validity. Psychometricians generally regard IQ tests as having high statistical reliability. A high reliability implies that, although test takers may have varying scores when taking the same test on differing occasions, and although they may have varying scores when taking different IQ tests at the same age, the scores generally agree with one another and across time. Like all statistical quantities, any particular estimate of IQ has an associated standard error that measures uncertainty about the estimate. For modern tests, the standard error of measurement is about 3 points. Clinical psychologists generally regard IQ scores as having sufficient statistical validity for many clinical purposes. Flynn effect. Since the early 20th century, raw scores on IQ tests have increased in most parts of the world. When a new version of an IQ test is normed, the standard scoring is set so performance at the population median results in a score of IQ 100. The phenomenon of rising raw score performance means if test takers are scored by a constant standard scoring rule, IQ test scores have been rising at an average rate of around 3 IQ points per decade. This phenomenon was named the Flynn effect in the book The Bell Curve after James R. Flynn, the author who did the most to bring this phenomenon to the attention of psychologists. Researchers have been exploring the issue of whether the Flynn effect is equally strong on performance of all kinds of IQ test items, whether the effect may have ended in some developed nations, whether there are social subgroup differences in the effect, and what possible causes of the effect might be. A 2011 textbook, IQ and Human Intelligence by N. J. McIntosh, noted the Flynn effect demolishes the fears that IQ would be decreased. He also asks whether it represents a real increase in intelligence beyond IQ scores. A 2011 psychology textbook, lead authored by Harvard psychologist Professor Daniel Schachter, noted that humans' inherited intelligence could be going down while acquired intelligence goes up. Aged IQ can change to some degree over the course of childhood. However, in one longitudinal study, the mean IQ scores of tests at ages 17 and 18 were correlated at r equals 0.86 with the mean scores of tests at ages 5, 6, and 7 and at r equals 0.96 with the mean scores of tests at ages 11, 12, and 13. For decades, practitioners' handbooks and textbooks on IQ testing have reported IQ declines with age after the beginning of adulthood. However, later research has pointed out this phenomenon is related to the Flynn effect and is in part a cohort effect rather than a true aging effect. A variety of studies of IQ and aging have been conducted since the norming of the first Wechsler intelligence scale drew attention to IQ differences in different age groups of adults. Current consensus is that fluid intelligence generally declines with age after early adulthood, while crystallized intelligence remains intact. Both cohort effects and practice effects must be controlled to gain accurate data. It is unclear whether any lifestyle intervention can preserve fluid intelligence into older ages. The exact peak age of fluid intelligence or crystallized intelligence remains elusive. Cross-sectional studies usually show that especially fluid intelligence peaks at a relatively young age, while longitudinal data mostly show that intelligence is stable until the mid-adulthood or later. Subsequently, intelligence seems to decline slowly. Genetics and environment. Environmental and genetic factors play a role in determining IQ. The relative importance has been the subject of much research and debate. Heritability. Heritability is defined as the proportion of variance in a trait which is attributable to genotype within a defined population in a specific environment. A number of points must be considered when interpreting heritability. Heritability, as a term, applies to populations, and in populations there are variations in traits between individuals. Heritability measures how much of that variation is caused by genetics. The value of heritability can change if the impact of environment in the population is substantially altered. A high heritability of a trait does not mean environmental effects, such as learning, are not involved. Since heritability increases during childhood and adolescence, one should be cautious drawing conclusions regarding the role of genetics and environment from studies where the participants are not followed until they are adults. The general figure for the heritability of IQ, according to an authoritative American Psychological Association report, is 0.45 for children, and rises to around 0.75 for late adolescents and adults. It may seem reasonable to expect genetic influences on traits like IQ to become less important as one gains experiences with age. However, the opposite occurs. Heritability measures in infancy are as low as 0.2, around 0.4 in middle childhood, and as high as 0.8 in adulthood. One proposed explanation is that people with different genes tend to reinforce the effects of those genes, for example by seeking out different environments. Shared family environment. Family members have aspects of environments in common. This shared family environment accounts for 0.25 to 0.35 of the variation in IQ in childhood. By late adolescence, it is quite low. The effect for several other psychological traits is similar. These studies have not looked at the effects of extreme environments, such as in abusive families, non-shared family environment, and environment outside the family. Although parents treat the children differently, such differential treatment explains only a small amount of non-shared environmental influence. One suggestion is that children react differently to the same environment because of different genes. More likely influences may be the impact of peers and other experiences outside the family. Individual genes. A very large proportion of the over 17,000 human genes are thought to have an effect on the development and functionality of the brain. While a number of individual genes have been reported to be associated with IQ, none have a strong effect. Deary and colleagues reported that no finding of a strong gene effect on IQ has been replicated. Most reported associations of genes with intelligence are false positive results. Recent findings of gene associations with normally varying intelligence differences in adults continue to show weak effects for any one gene. Likewise in children. Gene-environment interaction. David Rowe reported an interaction of genetic effects with socio-economic status, such that the heritability was high in high-SES families, but much lower in low-SES families. In the U.S., this has been replicated in infants, children, adolescents, and adults. Outside the U.S., studies show no link between heritability and SES. Some effects may even reverse sign outside the U.S. Dickens and Flynn have argued that genes for high IQ initiate an environment-shaping feedback cycle, with genetic effects causing bright children to seek out more stimulating environments that then further increase their IQ. In Dickens' model, environment effects are modeled as decaying over time. In this model, the Flynn effect can be explained by an increase in environmental stimulation independent of it being sought out by individuals. The authors suggest that programs aiming to increase IQ would be most likely to produce long-term IQ gains if they enduringly raise children's drive to seek out cognitively demanding experiences.